A 402 kilogram pile driver is raised 12 meters above the ground. There's three questions for this problem. A is how much work must be done to raise the pile driver. So here the force needed to apply on the pile driver is equal to its weight. So the force equals mass times gravity. Well, its mass is 402 kilograms. Gravity is 9.8 meters per second squared, and the change in x is 12 meters. Distance by which the pile driver is raised is change in x, so it's really y. So what I did was, to get the work, I multiplied the mass, gravity, and change in x, which is 402 kilograms, 9.8 meters per second squared, and 12 meters, and that gave me 47,275.2 joules, and I converted it to kilojoules, which is 47.3 kilojoules. And then the second part of the question is, how much work does gravity do on the driver as it is raised? The force of gravity and the direction of motion of the driver are opposite to each other. So what I did was, I took the work equals mass times gravity times change in x cosine theta, and I plugged all that in for what I knew, and theta is 180 degrees, and that gave me negative 47,275.2 joules, and I converted it to negative 47.3 kilojoules. And then the third question is, the driver is now dropped. How much work is done by gravity as the driver falls? In this case, the force of gravity and the direction of motion of the diver are in the same direction. So what I did was, I took the same formula, but for cosine theta, I plugged in 0 degrees since it's going in the same direction, and that gave me 47,275.2 joules converted to 47.3 kilojoules. And that is my reassessment for work energy.